Hi everyone. This is our last video on terminating and repeating decimals. This one we're going to focus on repeating decimals. So again, there are three categories of decimals. Decimals that terminate, meaning that they end in a finite number of digits. Decimals that repeat, which is going to be the purpose of this video. And then the non-repeating, non-terminating, which is the other category. And again, just to sort of connect all of these things, numbers themselves, if you think of this as the world of numbers, the real numbers are called. And real numbers are actually divided into two sets. There are rational numbers, and that symbol for that is Q for quotient. And there are irrational numbers. Quotient, or rational numbers, are all fractions. Anything that can be expressed as a fraction is considered a rational number. Anything that can't be written as a fraction, such as the square root of 2, pi, numbers like that are all irrational numbers. So in the decimal category, these first two correspond, as you will see, to rational numbers. This last one, non-repeating, non-terminating, all of those are the irrationals. So we're going to talk about repeating decimals, and remember, repeating decimals are decimals that have some block of digits that repeat. And just as we did with the terminating decimals, we're going to have a couple claims. All right. So claim number one about repeating decimals is that all numbers, all rational numbers, so a rational number is a fraction, a over b, written in lowest terms, that's important, where a and b are integers, and b, the denominator, is composed of primes other than 2 or 5, that number is a repeating decimal. So in other words, if you fully reduce the fraction and there is some factor, some prime factor in the denominator that's other than a 2 or 5, like a 7 or a 3 or 11, whatever's in the denominator, if it's not a 2 or a 5, then that fraction is a repeating decimal. So here's an example, 5/6. That would be 5 over 2 times 3. It can't be reduced. 3 is a factor. It's not a 2 or 5, so this would be a repeating decimal. How do you find that repeating decimal? There's a couple ways. So you can, first of all, you could do long division. You could say 6 into 5, oh, that's an awful gazinta, but 5.000. So 6 goes into 50, that's our decimal, so 8 times gives me a 48. So 20, 6 goes into 23 times, so that gives me 18, gives me a 20, 3 times again. Okay, I think I see the pattern here. And that would give me 2, bring down a 0, 3 again. So that decimal, 5/6, is the repeating decimal, 0.8, and only the 3 is repeating, 8/3 repeating. All right, so claim number 2 goes the other direction. So if you have a repeating decimal, then it can be written as a fraction. So again, claim 1 said, if you have a fraction that has denominator other than 2's or 5's, it's a repeating decimal. Claim 2 says the opposite, says if you have a repeating decimal, you can write it as a rational number, as a fraction, where the denominator is something other than 2's or 5's. And so what I'm going to do is we're going to focus the last 3 slides on this presentation are just going to be showing you how to do that. How do you take a repeating decimal and convert it to a rational number, convert it to a fraction? And so what I'm going to also do, I'm going to bring this up, is I'm going to bring up my calculator. And that would be helpful because it's always nice to check. All right, so where's my calculator? There it is. All right. Good. Okay, so 0.4 repeating. That's my first repeating decimal I'm going to look at. That is equal to, now the first thing you want to do when you do this process, remember the goal is what fraction gives us 0.4 repeating. I'm going to write it like this. I'm going to say, well, I'm going to call it a number. I'm going to say that's n. N equals 0.4 repeating, which is 0.444. You don't need to go too far. Okay, just get an idea. Now, there's one repeating decimal, one repeating place. So the 4 is what's repeating. So if there's one repeating place, I'm going to multiply this by 10 to the one repeating place, 10 to the first. So if I multiply 10 times 0.4 repeating, remember when you multiply by 10, you would just move the decimal place over. So 10, if n is 0.4 repeating, 10 n's is equal to 4.444 repeating. Now, what we're going to do is we're going to subtract those. So 10n minus 1n becomes 9n. So 9 of the numbers I'm looking for, remember n is this number right here, 9 of those numbers, and let's do the subtraction. So you have the 4's cancel. Oh, that's the nice thing about this. Cancel, 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 and you're left with equals just 4. So if 9n equals 4, then n equals 4/9. And now let's bring up the calculator and check. So I've got a calculator. I take 4 divided by 9, and that equals, oh my gosh, 0.4 repeating. Okay, so decimal number 2 has more decimal places, so 0.201. What does that number look like? All right, again, I'm going to call that number n, and n equals 0.201, 201, 201, and on and on and on. The whole block repeats. So what fraction represents that? All right. So there are 1, 2, 3 repeating places. So I'm going to multiply that number by 10 to the third, which is 1,000. Remember, if you multiply by 1,000, you're going to move that decimal place over 1, 2, 3. So 1,000, if n is equal to 0.201 repeating, 1,000 n's equals, okay, so I'd have 201.201, 201, 201, and so on. All right, and then subtract these again. Okay, so 1,000n minus n becomes 999n. What does that equal? Well, look at all this great stuff that's going on here. So we have all this cancellation. We have cancel, 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 cancel. It's all canceled. Equals 201. So 999 of the number, remember this number is what I'm going to call n. So 999 of them is equal to 201, and that says that 1n equals 201 over 999. Now often these can be simplified. For example, you might notice there's a 3 that the top is divisible by 3, the bottom's also divisible by 3. All we're saying in this claim is that you can express it as this ratio, as a fraction. Okay, here's one fraction that represents it. Let's check again. So in this case, I'm going to clear. I've got 201, 201, divided by 999. Oh, went one too far. There we go. And that equals 0.201, 201, 0.201 repeating. Our last number is 0.1245 repeating. Notice that the whole number doesn't repeat, just those last two digits. So that number that I'm working with, n we'll call it, so n equals 0.1245, 45, and on and on and on. Only the 0.45 repeats. There are, again, so that's my number. That's what I'm going to call my number. There are 2 repeating decimal places. So I'm going to multiply this number by 10 squared, or 100. You multiply by the number of repeating places, raise that 10 to that power. So if I do that, remember when I multiply by 10 squared or 100, I would move the decimal place over 2. So 100 of these n's equals, and I move the place over 2, it'll be 12.45454545, and we get all this great cancellation, but it's slightly different in this case. So what you have is you have some cancellation here, the 4, 5, 4, 5, 4, 5, but that's the extent of the cancellation. When you subtract, so when I subtract, what I'd be left with is we'd have 5 minus 2, which is 3, 4 minus 1, which is also 3 point. So 12.33, 100n minus 1n, that's 99n, equals 12.33. So n would equal 12.33 over 99, but I don't want to leave it like that. So I'm going to multiply the top and bottom by 100 to get rid of that decimal. And so you'd have 1233 divided by 9900. Let's check. Again, that probably, it would be able to be simplified, but all we're trying to do is express this as some fraction. Let's check. So in this case, we want to have 1233 divided by 9900, and let's see what it equals. Hopefully, oh, there it is, 0.1245454545, and that is the rational number that represents that repeating decimal.